Hello, fourth graders. Welcome to lesson 9.7, Compare Decimals. In this lesson, you will learn how to use place value and other strategies to compare decimals to see which one is greater than, less than, or if they're equal to each other. We will be working on problems from your math book and problems that require use of your math notebook, so make sure you have both available for this lesson. The main idea and takeaway when you are comparing decimals and kind of always and forever rule is this: line up the decimals. You must line up the decimals when you're comparing them, when you're adding them, when you're subtracting them, because we need to have the place values matching the other place value in the other number. So let's get started. We are going to look at the problem on page 533. And again, if you do not have your math book, you can just follow along. You do not have to write down this word problem or draw the models. Just follow along as I explain it to you. The city park covers 0 and 6,400 square miles. About 1,800 of the park is covered by water, and about 2/10 of the park is covered by paved walkways. Is more of the park covered by water or paved walkways? So that is our goal, that we're trying to figure out which one is covered more in this park. So one way we can use this is a model. So we are going to shade in 1,800s. In this first model here, we have one whole that's separated into 100 parts. So that's each one of those. There's 100 in this whole diagram for this first 1,800s. So to model that, you would shade in 18 of them. And in our 2/10 model, we have 10 equal parts, and we're shading in 2 of them. Then we compare the models to see which one has more shaded parts. And 2/10 has more parts that are shaded, which means 2/10 is greater than 1,800. Another way that we could have solved this same problem is by using a number line. So our first job is to find and locate 1,800 and 2/10 on that number line. So 2/10 is pretty easy to find. It's right there. It's the same as 20/100. And 1,800, we can think about that as 18, so I can count up from 1/10 or count backwards 2 jumps from 2/10 to find 1,800. Now, how do we use that to see which one is greater? Well, 1,800 is closer to 0. And any number that's closer to 0 is going to have a smaller value than a number that's farther away from 0 when we're talking about positive numbers. So 1,800 is still less than 2/10. Both strategies work perfectly fine, but if you are not in the time frame to draw models or use number lines that are split into multiple parts, we can use the most efficient way, which is using the place values. Now, using place values require you to follow kind of that golden rule of lining up the decimals. So this only works if you're paying attention and lining up the decimals correctly. So when you're comparing 1,700s and 1,300s, you can copy the second decimal right underneath the first one and compare their place values. Notice how all my ones are lined up, my tenths and my hundredths are lined up. So starting from the ones place, I can't tell which one's greater. The tenths place, still can't determine which one's greater because they have the same digit and the same place values. And finally, I get to my hundredths place, and now I can tell which one's greater. Right? 7 is greater than 3, so 1,700 is greater than 1,300. Something that you should always be thinking about, and we've previously worked with decimals, is think about this as money, right? 1,700 is the same as 17 cents. And 1,300 is the same as 13 cents. Which is greater, 17 cents or 13 cents? 17 cents, correct. So again, think about it in terms of money, right? Using that to help us with these last two. On this page, we have 4,500s and 6,300s. So I'm going to copy the second number right underneath the first one, making sure my place values are all lined up. Ones place can't determine a greater value, and I get to the tenths place and I realize that 4 is less than 6, so I don't have to go any further to the hundredths place because my tenths place tells me that 6 is greater than 4. So therefore 63 hundredths is greater than 45 hundredths, and 63 cents is greater than 45 cents. So using that money reference to double check my answer confirms that 63 cents is greater than 45 cents. All right, number 3, again, copy down your second decimal, make sure everything is lined up, and start comparing. So I'm looking at the ones place, and I already was able to figure out which answer was greater. So 1 3/10 is greater than 6/10. A couple ways you can think about that, right? 1 3/10 is the same as $1.30, and 0 6/10, you can think about that as 60 cents. So which would you rather have in your pocket? I'd rather have $1.30 in my pocket, right? Also, you can think about that there's a number in the ones place that's greater than 0 versus the 0 in the ones place in 6/10. 1 is always going to be greater than 0, so I didn't even have to look at the digits in the tenths place. Okay, we're moving on to our last 2 problems, which can be a little trickier. So make sure you're paying close attention to these last 2 problems. Alright, these problems are trickier and most students get these confused, so these are common mistakes that a lot of students make on these types of problems. So again, make sure you're paying close attention. A couple ways you can think about these. You can think about them in terms of fractions and use our knowledge about fractions to help us compare them. So for this first decimal, we have 4/10, and I can rewrite that as a fraction as 4/10. For this second decimal, 40 hundredths, I can rewrite that as 40 hundredths. Then I can compare these 2 fractions. So when I'm comparing 4/10 to 40 hundredths, I notice that they are equivalent, and I rewrote it to make it a little bit more clearer. So I know that 4/10 and 40 hundredths are equivalent fractions. They're just written with different denominators, right? Because I can do each the denominator and the numerator times 10 and get the same value. Another way you can think about it besides fraction is again referencing that money that we were talking about before. So 4/10 can be written as 40 cents, right? And so can 0 and 40 hundredths also be written as 40 cents. I can add as many zeros as I want to the end of a number, and it still remains that same value. So even though I've added multiple zeros after the 4 in the tens place, they still remain the same value. Only when we add zeros in front of the 4 does that change things. So again, these are equivalent and they're worth the same amount because I can add zeros in place values behind the ones that I'm comparing and it still stays that amount. Now this is the exception to that rule which I was referring to earlier. So again, for number 5, we have a very commonly answered, a question that's commonly answered incorrectly for number 5. So for this first decimal over here, we have 5 hundredths as a fraction, and then we have 5/10 as a fraction. Those are not equivalent fractions because from 100 to 10, I can divide by 10, and whatever you do to your numerator, you have to do to your numerator, and I cannot divide 5 by 10 and still end up with 5. So these are not equivalent. Okay? I can also use that same method that I was using before where I copied down the numbers underneath each other and lined up my decimals. So when I do that, I check off the ones place, okay, they're the same digits. Move over to the tens place, aha. Here in the tens place, 5 is greater than 0, so therefore 5/10 is greater than 5 hundredths. And the last and third way you can think about this as is 0 and 5 hundredths, that's the same as 5 cents, right? 1 nickel. If you have 0 and 5/10, that's the same as 50 cents, because remember I can add zeros to the end of numbers and it still stays the same. So therefore 50 cents is always going to be greater than 5 cents. So many different ways you can think about these when you're using place values. You can use the money way, you can use the lining up the decimals method that I have here in the charts, or you can use them as fractions. Here are your 5 practice problems. They are the problems on Share and Show in your math book, and you can complete them there. They're on page 535, numbers 1 through 5. If you did not bring your math book home with you, I've written them here for you. You are just simply saying which decimals are greater than, less than, or if they're equal to each other. All right, enjoy the rest of your day.